Consider how you use a computer in a typical day. For example, you start working on a report, and once you have completed a paragraph, you perform a spell check. You open up a spreadsheet application to do some financial projections to see if you can afford a new car loan. You use a web browser to search online for a kind of car you want to buy. You may not think about this very consciously, but all of these operations performed by your computer consist of algorithms. An algorithm is a well-defined procedure that allows a computer to solve a problem. Another way to describe an algorithm is a sequence of unambiguous instructions. The use of the term unambiguous indicates that there is no room for subjective interpretation. Every time you ask your computer to carry out the same algorithm, it will do it in exactly the same manner with the exact same result. Consider the earlier examples again. Spell checking uses algorithms. Financial calculations use algorithms. A search engine uses algorithms. In fact, it is difficult to think of a task performed by your computer that does not use algorithms. Let's take a closer look at an example. A very simple example of an algorithm would be to find the largest number in an unsorted list of numbers. If you were given a list of 5 different numbers, you would have this figured out in no time. No computer needed. Now how about 5 million different numbers? Clearly, you are going to need a computer to do this, and a computer needs an algorithm. Here's what the algorithm could look like. Let's say the input consists of a list of numbers, and this list is called L. The number L1 would be the first number in the list, L2 the second number, etc. And we know the list is not sorted. Otherwise, the answer would be really easy. So the input to the algorithm is a list of numbers, and the output should be the largest number in the list. The algorithm would look something like this. Step 1. Let largest equal L1. This means you start by assuming that the first number is the largest number. Step 2. For each item in the list. This means you will go through the list of numbers one by one. Step 3. If the item is greater than the largest. If you find a new largest number, move to step 4. If not, go back to step 2, which means you move on to the next number in the list. Step 4. Then largest is equal to the item. This replaces the old largest number with the new largest number you just found. Once this is completed, return to step 2 until there are no more numbers left in the list. Step 5. Return largest. This produces the desired result. Notice that the algorithm is described as a series of logical steps in a language that is easily understood. For a computer to actually use these instructions, they need to be written in a language that a computer can understand, known as a programming language. There are many different types of algorithms.